First of all, let's talk about light and sight. So this is light and sight. Now light is a type of wave and also a type of particle, but I'm not going to talk about that. I'm going to talk about more generally light and sight. So first thing, if someone says what is light, so the answer should be light is an electromagnetic wave, and it is part of the electromagnetic spectrum, and that is light. Sight is that how you see. So whenever people are talking about sight, they're talking about seeing, how we see things. So light is the actual object, the actual electromagnetic wave. I said that it's an object because it is also a particle. It is both a particle and a wave, and it is part of the electromagnetic wave. So light is that and sight is how we see. Let's start with, first of all, let's start with light rays. What are light rays? Well, light rays. Light rays, the first thing that talks about where does light come from? Well, light comes from objects that have their own light, which we call it luminous objects. Luminous objects means it's their own light. Like the sun is a luminous object, so light comes from there. Another source of light is reflected light from non-luminous objects. Non-luminous objects not own light but borrowed light or reflected light. Reflected light. So like the moon, so we also get light from the moon. For example, at night you have moonlight, and that's not bad for a dark day. So even you have moonlight, and sun, of course, it's the source of all the light. So when we're talking about light rays, we are talking about how light travels. It travels in straight lines, it can travel through vacuum, but we are also talking about where does it come from. It comes from luminous objects. Like a bulb, it's luminous objects. And there's also some sort of a shiny, you will see some sort of a halogen lamp, it will have a shiny background like a mirror. That's the non-luminous object, but it reflects light, a lot of light. Even a wall that has a bright painting on it, the room looks brighter because it reflects the light, but it is non-luminous. Now rays is like this. This is a ray of light, but when we have many rays together, packed together, we call it a beam of light. So that's how it works. And when you see that a light is blocked, we call it a shadow. A shadow is absence of light. It means if you stand between the source of light and the screen or something, the place that you are blocking the light, because light cannot travel through you, so there will be a silhouette, a dark, a shadowy structure, and that's called the shadow. It's actually the absence of light. And shadows can be broken down into umbra and penumbra, where is complete darkness and there is partial light. And part of the example of shadow of light is the eclipse that we have, the solar eclipse and the lunar eclipse, where in case of the solar eclipse, what happens is that we cannot see the sun because the moon actually blocks it, and the shadow of the moon falls on the sun, and that's how it works. And the reason it blocks, because although the sun is much bigger than the moon, but the distance of the sun and the moon is situated in such a way, just like a magical object, the moon in total solar eclipse completely blocks the sun. So that's how it works. Now the next thing we should talk about is the reflection of light. Now in case of the reflection of light, the first thing we have to talk about, what are the law of reflection? The law of reflection is pretty straightforward. If you have a surface like this, a mirror, and if we draw an imaginary line, let's call this the perpendicular line or the normal line. If an angle comes here, ray of light comes here, since it's coming, first of all we'll call it the incident ray. The incident ray. So that's the incident ray, and the angle it makes with this normal is called the angle of incidence. Now when it hits the surface, it can be the mirror or any shiny surface, it will be reflected, and it's called the reflected ray. The reflected ray. And the law of reflection says that the reflected ray and the incident ray, they're equal. So this is very simple. So it's reflected ray, angle of reflection and angle of incidence, they're equal. That's the law of reflection. Now when you're talking about the law of reflection, you have to understand, using this law of reflection we have objects like the periscope, that is used in submarine. It is like this. Underwater you can see on the other side. Of course light cannot travel like that, but if you have mirrors here and mirrors here, so light from that object will come, it will reflect, it will come here, reflect, and it will come out. So in a way you will be seeing something that is outside. So underground in the water, using the periscope, you can see something above using the law of reflection. So it can be used. Now reflection can be on a shiny surface, then you can actually see your face, the reflection will be so good. But reflection can also happen on a diffuse surface, like on a wall. On a wall you cannot see your own face, but light is being reflected, because I said just now it is a non-luminous object. So just reflection, usually you think the reflection is on a mirror, you can see your face. No, not necessarily. On a wall there can be a reflection, and that reflected light can also, you can see the fact, you see through reflection all the light bounces off other objects, and you see that. So that's how reflection works. The next thing we talk about, naturally we should talk about mirrors. Now while talking about mirrors, we can say that mirrors are something that are very, very common. And for understanding this concept, you have to know what happens in a mirror. Well, when you have a mirror, certain things work to the object. First of all, the image that you get from a mirror, that image is not real, it's virtual. What does that mean? It means you cannot have the image that you see in the mirror, you cannot have it on a screen. It is always inside the mirror. So anything that cannot be projected on a screen, like a movie we project it on a screen, we can see it. Anything inside a mirror, that image cannot be projected on a screen, so we call it a virtual image. The next thing, the image is the same size as the object. I'm not talking about magic mirrors here, I'm talking about the regular mirrors. If you stand in front of a mirror, you will see that your object inside the mirror is the same size as you are. And another thing is that it's same distance. So if you stand in front of a mirror, your distance from the mirror is the same as the distance of the image, your image from the mirror. They have the same distance, they look the same. So if this is the mirror, if you stand here, the image that will be formed from an equal object and image. It will have an equal distance. So that's the idea. So whenever we are talking about mirror, it will be virtual image, it will be same size as the object, it will be same distance as the object. And another thing that we have is it will be laterally inverted sideways. Laterally inverted. Laterally inverted means, suppose you have a mirror here and you write an E. In the image, the E will look like this. It will be inverted. Laterally inverted means inverted sideways. So this is laterally inverted. So this is how the image looks like in the mirror. The next thing naturally is refraction, which is actually more important and more useful in physics. Refraction. So when we talk about refraction, we are actually talking about the bending of light. We are talking about the bending of light. So the bending of light means when light travels from one medium, suppose air, it has a different speed, and when it enters glass, the speed slows down because the density is more. So when that happens, light bends. So light is actually bending because the speed of light is actually decreasing. Yes, light is very fast, but slightly, even if the speed decreases, it bends. So this is what happens. So suppose this is a heavier block, glass block, which is heavier. This is glass and this is air. So let me call this the normal now, the perpendicular line. So if light enters, the angle of incidence it makes with the normal, now it will bend away. So this will be a bigger angle. So the angle of refraction will always be bigger if it goes from air to glass, because glass, no, the angle of incidence, I think I made a mistake. The angle of refraction will always be smaller, it will bend towards. If it is lighter, it is faster, so it is away from the normal. If it is more dense object like glass, it will bend towards the normal. So what would happen? It would bend towards the normal. So more dense medium, that means light will bend towards the normal. Less dense, it will move away from the normal. So this is actually the law of refraction, and when it comes out, it will always be parallel. So when it comes out on this side, again it will bend away from the normal. So this and this will be parallel. So this ray and this ray will be parallel. Now if you want to know the purity of an object like diamond, where we have a light passing through it, you can actually know the purity of the object by looking at this ratio of refraction. How much angle does the angle of incidence make with the normal, and how much angle does the angle of refraction make? So that's called the refractive index. Refractive index, denoted by an N, and the refractive index is sine ratio of the incidence angle divided by sine ratio of the refracted angle. So if you do that, you'll find the refractive index, and using the refractive index we can actually find the purity, whether the object is pure or not, and that's what diamond sellers use. Now one more thing that we should talk about is dispersion, a concept of dispersion. Dispersion is actually how light is dispersed or spread out as it travels through a hole. And suppose if light is traveling through an opening which is equal to its own wavelength, we'll talk about wavelength later on, then it is dispersed more like this, dispersed out like this. So that's how light is dispersed. But if the opening is much larger than its wavelength, then the dispersion would be not that like that, it will be more spread out. Dispersion will be like that. So let me scroll this. So the dispersion will be like that. So whenever we are talking about that, so the dispersion depends on the opening through which the light passes and how it is going to be spread out. Now one thing that there is something called total internal reflection. Total internal reflection is total internal reflection. Total internal reflection is working on the principle of reflection and also refraction. That's what's happening. So what happens here is that, suppose you have an object. Now that object, it's like this. So suppose it's a piece of glass. So this is glass, more dense, and this is air, less dense. So suppose you have a ray of light which is like this. So when it is passing from more dense to less dense, remember its speed will increase because now it has less resistance, so it will move away from the normal. So it will move away from the normal. Now suppose there is another ray which is a bit further away from the normal, a bit further away from the normal, then it will move further away as it comes out from the normal. Now this will happen. Suppose now we have another ray which is even further away from the normal. Time will come where the angle that this makes, this angle will be completely 90 degree. It has moved so further away from the normal that the angle of incidence, which is now inside the glass, and the angle of refraction, it will be 90 degree. So this angle of incidence, which makes the angle of refraction 90 degree, now this is then called the critical angle. The critical angle. Critical angle means an angle of incidence which makes the angle of refraction become 90 degree with the normal. Now any angle larger than the critical angle will cause in total internal reflection, meaning now there will be, instead of refraction, there will be reflection. So any angle larger than the critical angle will enter the glass itself in the form of a reflection. So that means any angle larger than the critical angle, the angle of incidence will be equal to the angle of, not refraction, now it is reflecting. So this happens so many times, so many places, especially if you see the diamond. So it glows and glitters. So that's the concept of total internal reflection. Now in physics there are always about the talk about ray diagrams, how you draw a ray diagram, what you do about it. So that's that's something that should be discussed separately, because that's a lecture of its own. So in a nutshell, so this is the basic concepts of what's light and sound and how we deal with it, and that's it.